Hello guys, good to see you back. Once again, I am back with a new tutorial. And today in this tutorial, I am going to show you how MediaPipe post detection works. In our previous tutorials, we learned how to detect hand and how to recognize hand landmarks. But in that tutorial, we are going to recognize body structure with the help of OpenCV and MediaPipe Task API. Before our upcoming project, it is important to know how to detect body posture. So let's go to the computer screen and see how it's work. Let's try to understand how it's work. How machine learning programs read our body structure. At first, as you know, we need to capture the frame from our webcam. Otherwise, you can use pre-recorded video. Next, we need to use AI model that going to process the frame. In our case, MediaPipe introduced total 3 AI model: light version, full version and heavy version. We are working with modern Task API, not old solution function. That's why we need to download task file. These are pre-trained models that recognize body pose structure. If we talk about the light version of poselandmarker.task file, if I talk about its characteristics, it is the fastest model, lowest CPU usage, and lowest memory usage. Also, it provides lowest accuracy among the three. It is best for real-time webcam application, drones, robots, gesture control, Raspberry Pi projects and old laptops. If you don't have powerful hardware, then you can use that model. And the advantages of use the light version is it processes high FPS, low latency, and runs smoothly on any low-end hardware. But also there are some disadvantages, such as less accuracy when person is far. Also, it did not work properly when body is partially hidden. Next, it provides full version, post landmarker underscore full version. If I talk about its characteristics, it is provide balance speed and accuracy. Also, it is the most commonly used model. It is best for general purpose post tracking, fitness application, exercise counter, yoga detection, educational projects. If I talk about its advantages, it provides better landmark accuracy, still work in real time in most computers. Also, good compromise between performance and quality disadvantages. But it is slightly slower than light version. Most of the time we use that, but not for drone project. Then comes the heavy model. It provides highest accuracy, largest model size, and highest usage of CPU and GPU. It is best for professional motion analysis, research object, biomechanics, sports analytics, precise body tracking. If I talk about its advantages, it provides most stable landmarks, better tracking of difficult pose, better depth estimation. Also, it comes with some disadvantages such as lower FPS, require more powerful hardware, and it is not ideal for low-end systems. That's why we do not use that. We do not use it project like drone controlling. And to download the models, just search post landmarker task download. Then it provides the link, and that's the official link post landmarker detection guide. Open this one, and after that, as you know, we are working with Python programming language, so I'm going to select Python. After select Python, scroll down a little bit, and here it provides the models. It provides the MediaPipe post landmarker task models. And if you click on the model selection option, you can see all of these models such as post landmarker light, full and heavy. And according to your needs, you can download this model by clicking the link. After clicking the link, as you can see, it downloads the models in your system. It's up to you. In that tutorial, I would like to go with the two version, light and full. I'm going to test this two version. So you can download it and put it in your current working directory. Now look at the structure of the human figure. This is how MediaPipe model read our body structure. It divides the whole human figure into 33 landmarks. It starts from 0. 0 represents the nose. Then 1, 2, 3. 1 represent right eye inner, 2 represent right eye, 3 represent right eye outer. If I talk about the key points, it can detect nose, eyes, ears, shoulders, elbows, wrist, hip, knees, and ankles. It can detect whole human structure, body, joints. Now, as I told you earlier, MediaPipe Pose Landmarker create 33 different landmarks. In our previous tutorials, we already learned about hand landmarks. Hand landmark model detect 21 hand landmarks, but Pose Landmarker create 33 different landmarks. And every landmark number represent every part of our body. So, if we use 0, then it represents our nose. If we use 10, it represents mouth left. But for this particular tutorial, we need to create that skeleton structure in our frame. Also, we need to draw the landmark points. We need to understand this structure because in our upcoming projects, we are going to use that. So, without talking too much, let's start the practical. Now, before we start the practical, don't forget to check out the description of this video. If you are very interested to learn OpenCV and computer vision from the very beginning, then check out the link at my description. Here I provide a Udemy course link. And it is the bestseller course on Udemy. So do not miss out it. So let's get started and start the practical. So finally, we are in my Visual Studio Code editor. As you can see in my current working directory, I already create a Python file named body.py. Also, you can see in my current working directory, we have two task file, pose landmarker full.task file and pose landmarker light.task file. We have total 2 AI model. And if you would like to work with the most accurate version, in that case, you can use pose landmarker heavy.task file. But for now, it is good for us to work with full and light version. So without talking too much, let's start coding. First, I'm going to import CV2. So here I'm going to type import CV2. As you know, we need CV2 to accessing webcam, processing image and displaying windows. Then after that, I'm going to import MediaPipe. I'm going to import MediaPipe as MP. It's going to import the MediaPipe library. It is used for AI-based landmark detection. Next, we need to import MediaPipe Task API Python module. For that, here I'm going to type from MediaPipe.task, I want to import Python. It gives access to task-based model such as hand landmarker, pose landmarker, and face landmarker. In our previous tutorials, we learned about hand landmarker, but in that tutorial, we are going to learn pose landmarker. After that, we need to import vision. We need to import vision from MediaPipe Task Python module. So here I'm going to type from MediaPipe.task.python, I'm going to import, here I import vision. Here we import vision related classes. Next, we need to import a new thing. We need to import a protocol buffer landmark structure from MediaPipe frameworks. So here we need to type from MediaPipe.framework.formats import landmark underscore pv2. Now the question is why we need that. It is needed because the Task API return landmark in a format that OpenCV drawing utils cannot directly use. Using that, we can convert landmark into normalized landmark list, so MediaPipe can draw them. After that, we need to set up the pose landmark. For that, here we need to type base option equal to python.baseOption function from MediaPipe. Python.baseOption class from MediaPipe. Then inside the round braces, we need to define model asset path. And here I assign model asset path pose landmarker light.task file. This one. This model contains the trained neural network. And this model provides fast speed but low accuracy. Don't worry, next we will try with full version also. But for fastest result, I use light version. After that, we need to create pose landmarker configuration. For that, here I'm going to type options equal to vision.pose landmarker option, and inside the round braces, first I said base option, this base option, running mode vision.running mode.video because it tells MediaPipe that frames come from a video stream. And as I told you earlier, there are 3 options: image, video, and live stream. But if you use webcam, you need to use video. Then number of pose we allowed. So at the same time, it's going to detect only one figure. If you have multiple figure in front of camera, then it's going to select the first one, the first figure. If you set it 5, then at the same time it's going to detect 5 people. And if you set 1, at a time it's going to detect 1 people. Then after that, we need to create the actual pose landmarker object. So I'm going to define a variable pose landmarker equal to vision dot pose landmarker dot create from option. This class, this function. From vision module, here I call this variable pose landmarker and I run that function create from option. And inside the round braces, I pass option, the option we create earlier. And now it is become an actual object. And now our AI is ready. After that, we need to focus on drawing utils. Here, I'm going to load MediaPipe drawing tool. For that, we need to type a variable. You can type any variable. In our case, I'm going to type mp underscore drawing equal to mp.solution module dot drawing utils. This one used to draw circle, lines and landmarks. After that, we need to load pose module. So I'm going to type mp pose MediaPipe pose equal to mp.solution.pose. This pose module contains skeleton connections. Now at the next part, we are going to set up the camera. So at that section, I'm going to type a single line comment camera, and here I'm going to type cap equal to cv2.video capture method, and inside the round braces I want to start the default webcam, so I select 0. Also, we need to initialize timestamp with 0 because we are working with Task API. That's why we need that. Basically, this variable going to store video timestamp. And we need that because MediaPipe tracks motion across frames. Next, we are going to start the main loop. And you know the process. So, we need to type while true. After while true inside the while loop, here we need to read the frame using read method, cat.read method. And as you know, this method return total 2 result, frame itself and a boolean value. In our case, I store it in a success variable. And then I'm going to set a if condition. If not success, then inside this if condition, I want to break the loop. Break. That's it. After that, I'm going to mirror the image. We need that. Next, we need to convert BGR to RGB. So here I'm going to type RGB equal to I'm going to use cv2.color method, and here I'm going to change the color of our frame. So I type, first I provide the frame and then I use cv2.color BGR to RGB. By default, OpenCV read our frame in BGR color mode. But whenever we need to work with Task API, otherwise MediaPipe, in that case we need RGB color frame. Then after that, I'm going to create the MediaPipe image object. So I define a variable mp_image equal to mp.image. From MediaPipe, I call image. For MediaPipe, I import image. And inside the round braces, first to define image format equal to mp.imageformat.srgb. Then data equal to RGB. It is a specific image format. sRGB means standard RGB. And data equal to RGB, this variable mean here it passes RGB frame. So here we complete the MediaPipe image object. After that, we need to run pose detection. So here I'm going to type result equal to, we need to run a function and we call that function detect for video. And some type result equal to pose landmarker, object, and in that object I run that function called detect for video. And inside the round braces, in that function, first we provide the input frame, which is mp_image, this variable, and also we need to pass timestamp. It is the current frame timestamp. Then also we need to increment the timestamp value. So here I'm going to type timestamp plus equal to 1. For every iteration of while loop, it's going to increment the value with 1. Next, I'm going to draw the skeleton of our body. So here I'm going to type draw skeleton a single line comment, and then I'm going to use if condition. Here I'm going to type if results dot pose landmarks. Then inside this if condition, I want to run a for loop. Here first we check if body was detected. Then we loop through detected people. So I type a for loop for pose in results.pose landmark. And as you know, here we allow only one number of pose. That's why it's going to detect only one person at a time. Then inside the for loop, I'm going to create a empty landmark list. So I'm going to type pose landmark photo equal to inside the round braces landmark underscore pb2 from this module. I want to use this function normalize landmark list. Basically, this is going to create an empty landmark list, and MediaPipe drawing tools require this format. Otherwise, it cannot draw the points, line, etc. Then inside this for loop, we need to run another for loop. Loop through landmark points. So here I will type for landmark in pose. For landmark in pose, then inside this for loop, basically it iterated through all the body landmarks, and as you know, it returned total 33 landmarks, 33 body landmark points. And you know, each of the landmark return total 3 value: x-axis, y-axis and z-axis, horizontal coordinate, vertical coordinate and depth. So inside the for loop, I'm going to type pose underscore landmark underscore photo dot landmark dot add method. Then inside the round braces, we need to extract all the value from the landmark, such as to extract the x value, I type landmark.x. To extract the y value, I type landmark.y. And to extract the z value, here we access landmark.z. And the last parameter is visibility. Visibility equal to landmark.visibility. It is the confidence that landmark is visible, and it set range between 0 to 1. Next, outside the for loop, we need to draw the landmarks. So I'm going to type mp underscore drawing dot draw landmarks. Then inside the round braces, we need to set the credentials, such as first I'm going to pass the frame where we are going to draw. Then we need to pass pose landmark photo. After that, I'm going to pass the connections, pose mp pose dot pose connections. Then we need to define a function. Here we need to define mp drawing dot drawing specs. Here I said thickness 2 and circle radius 3. Now what basically we done here? This function, this single function, is responsible for drawing the entire pose skeleton on the image. Let's background it argument by argument. First, in that function, in draw landmarks function, we pass frame. This is the image where the pose will be drawn. Then comes pose landmark photo. This contained all detected body landmark. Example, at landmark number 0, we have nose. At landmark number 11, we have left shoulder. At landmark number 12, we have right shoulder. And each of the landmark contained x-axis, y-axis and visibility. We create that earlier. And then we run pose mp pose dot pose connection. This tells MediaPipe which landmark should be connected. For example, shoulder to elbow, 11 to 13, elbow to wrist, 13 to 15. Also hip to knee, 23 to 25, and knee to ankle, 25 to 27. Internally, it is a set of landmark pair, so we don't need to create it manually. After that, we define the landmark style using drawing specs, mp drawing dot drawing specs, and we set thickness 2, border thickness of landmark circle 2. Okay, then we define the circle radius, and we set circle radius 3. And next, for the common style such as lines, here again I'm going to call mp drawing dot drawing specs, and inside the round braces, this time I'm going to set thickness equal to 2. That's it. Basically, here we style the lines thickness. We define the thickness of the skeleton lines and we set it to 2 pixels. So we are almost done. Now, outside this if condition, so I'm going to move out from this if condition, and here I'm going to display the window, the main window, where we are going to show the result. And I'm going to type cv2 dot I'm show method, and and our window name is pose line marker, and I want to display the frame itself because we draw all the lines and landmarks in our frame. After that, I'm going to run the wait key method. So here I'm going to type cb2.waitKey. I'm going to wait for 1 millisecond, and I'm going to set if condition. If we press Q in our keyboard, then I want to break the loop. Otherwise, if you want to quit the program, if you press escape key, for that you can type 27, the escape key code. And then come the cleanup part. So outside the while loop, I'm going to release the capture. Also, I'm going to destroy all the windows, and I'm going to save this file. Now to save this file, let's run the code in our terminal and see is it work successfully or not. Is it detect our body pose or not? First we try with the light model, then we try with the full model. So let's save the file and run the code in our terminal. So let's hit the run button, and after hit the run button, we need to wait for some time to start the webcam. Now to wait for some time, as you can see, it open a window pose line marker, and it already start tracking my body posture. You can notice the joints of elbow, shoulder, hip joint, and if I move my leg, also it creates the skeleton on my leg. And if I move my hand any direction, you can notice skeleton move with that. Also it track my eyes, nose, mouth, eyebrows, etc. Here we test our program with light model. Now I'm going to kill the terminal and I'm going to rerun the code with full model. So after kill the terminal, I'm going to scroll up the page, and here I'm going to change the line marker. I'm going to replace light with full, and then again I'm going to run the code in my terminal. It is a little bit slower, but it is quite accurate. Now after wait for some time, as you can see, it opened the window. Now if you compare with our previous model, you can notice our previous model is not able to track the lower portion of our body because it was fast but not accurate. But in full version, it accurately detect the joints and draw the landmark. Also it draw the lines. At the same way, if you want to try the heavy version, yes, you can just replace with heavy. So this is it for this tutorial. I hope you enjoy this project. Thank you very much. See you soon.